Hello and welcome to Mr. Ridley's Design and Technology. In this clip we're going to look at technical writing. What we have here is a description of using the laser cutter. It uses technical writing. I'm just going to go through this and we're going to look at the technical words that are used in it. Making a keyring with the laser cutter. To begin the process of cutting out the keyring from 4mm plywood sheet using the GCSE Laser Pro X252 laser cutter. The first step is to ensure that the design is complete in TechSoft V3 software. The keyring image drawn with precision using TechSoft V3 software includes the outline and any details such as engraving, text or logos, which will be transferred to the laser cutter later. Once the design is finalized, it must be converted into a vector format that the laser cutter can read. Next, the file is transferred from the laptop to the laser cutter via a USB memory stick. Insert the USB stick into the laser cutter's own laptop, ensuring that the image is correctly positioned and tessellated with other keyring images that you are going to cut to ensure the most economic use of plywood. Using the laser cutter's laptop, navigate through the options to select and load the design file. Once the file is loaded, it's important to set up the laser cutter parameters, such as cutting speed, power and frequency. These settings will depend on the thickness of the plywood, in this case 4mm, and the desired quality of the cut. A typical setting might involve lower speed and higher power for cutting and moderate power with a slower speed for engraving if applicable. With the settings configured, place the 4mm plywood sheet onto the laser bed, ensuring it is properly aligned and flat and level on the bed of the laser cutter. Then close the lid and set the Z height to 0 by pressing the autofocus button. This allows the laser cutter to know the thickness of the material, which is 4mm, and it is also good practice to perform a test run on a scrap piece of plywood to check that the settings are correct and the laser cuts cleanly through the material without burning or charring the edges. After the test is successful and the drawing files are complete, transfer the files from the laptop to the laser cutter. Once the files have transferred and you are ready to cut, turn on the extraction unit, and once the extractor is on, you can press the red start button to commence the cut. The laser will precisely follow the outlines in the design, etching and cutting out the keyring shape from the plywood. Afterwards, carefully remove the keyring from the bed and inspect the edges for any roughness or charring, which can be cleaned up with light sanding if necessary. The result is a finely cut, personalised keyring ready for use or further decoration. Okay, now we're just going to go over 3 words there that were in that text that you might not have encountered before. First word was tessellate. Tessellate is to arrange, in tessellate, in the form we're using is probably in mathematics, is to arrange or fit together shapes in a repeated interlocking pattern. When we're putting CAD drawings onto a piece of work, we try and tessellate them, make the shapes fit together as best as possible, so we use make the most economic use of material. It comes from tessella, from Latin, which means small square tile. You see there Roman mosaics or tessellas. Next word, engrave. Engrave means to cut or carve a design into a hard surface such as metal, stone or wood. The inscription on tombstones is said to be engraved. There's also another meaning, which means to impress deeply on the mind or memory, because if you engrave something, it's there. It's not just written on it, it's carved into it. So you might say to carve into your memory. You can see there an example of laser engraving that we do on the laser cutter. And last of all, we mentioned Z-axis. In three-dimensional coordinate system, so when you've got x-axis and y-axis, that's in 2 dimensions. When we add a third dimension up and down, we refer to that as the z-axis. When the laser cutter comes down and measures the thickness of the material, which I said was 4 millimeters, that's the laser head moving in the z-axis. So that's where that comes from. Okay. Well, thanks for watching Mr. Ridley's Design and Technology. I hope you found that helpful.